The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to Tech Geek webinar series, our endeavor to empower techies. We believe that sharing of knowledge is key to enhance our skills and grow us as a professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insights of various domains. The topic of today's session is Intel tool to maximize your Android app performance, and our guest speaker for today's session is Mr. Ghanshyam. He is Head Technology and Ecosystem Enablement. Ghanshyam head the Technology Enablement business for BI Head Private Limited. In this capacity, he is responsible for helping clients to realize the true potential of the technologies that run their businesses. He has over 10 years of experience spanning a variety of areas, including technology evangelism, audience marketing, project management, and hardcore project development. On being a passionate technology enthusiast, Ghanshyam is always looking for the ways to engage with the IT ecosystem to come up with a solution for challenges that we face on a day-to-day basis. A designated Intel software innovator, he has proven his skill at mentoring and showcasing innovative solutions to fellow developers. So without any further delay, I introduce you all to our guest speaker. Over to you, Ghanshyam. Ghanshyam, we can see your presentation. Ghanshyam, please check your audio system. Your voice is not coming. Please unmute yourself, Ghanshyam.
Okay, can you hear me?
Yeah, we can hear you, Ghanshyam.
Oh, okay, thank you. So good afternoon all. Welcome to today's webinar. Today I will be talking about the various tools from Intel which will help you maximize your Android application performances. Without any difficulty, get started. So these are the different tools I will be talking today. It's Haxum, the threading building blocks or TBB, Intel graphics performance analyzers, Intel's integrated performance primitives, Intel XDK and INDE or INDE. So one of the for any Android developer always has been the emulator. So emulators are very slow. They are very slow in terms of responsiveness, and also it takes a long time for you to start the emulator. So most of the time, like I have heard developers telling that the moment they start the emulator, they can go have a coffee and come back and still the emulator will be loading. So to overcome that, Intel has come up with something called Intel Haxum or Hardware Accelerated Execution Manager. What this particular tool or what this particular application does, if your system is an Intel-based PC which supports VT, the virtualization technology, you can install this tool and it ensures that your Android image or the Android emulator faster. You can install this tool from downloading from the Intel website, or you can install this from the Android SDK manager. So you need to, the last option in the extras is the Intel Hardware Accelerated Execution Manager. So you need to install it. At the same time, you need to also install a system image. So for the version of Android you are looking for or you are developing, you need to download and install the system image. Let me show you an example, or let me show you the sample of how faster the execution is with the Intel Haxum and the default Android emulator. So first, I will show you the tools installed. So on this machine, I have installed the Intel image for Android 4.2.2. And under the extras, you can see that the last option, Intel x86 emulator accelerator, is installed. So these are the two components which you need to install from your Android SDK manager. Next, I am going to start both Android, the default emulator image and the Intel emulator image. So first, I will start the default emulator image. And at the same time, I'll start the Intel emulator image. So I have both the windows coming up. So you can see that the Intel image has already loaded. So the right side is the Intel emulator image. You see that the Intel image is already loaded, whereas Android is the default emulator is still booting. So let me continue with the other tools. So this HackSim is available for Windows and Mac users. And for Linux users, the Intel virtualization technology is supported by something called QEMU KVM. So for Linux, it's the QEMU KVM which does the accelerated emulators instead of the HackSim technology. Next, I will be talking about Intel threading building blocks, or Intel TBB. Intel TBB is a set of APIs, is a set of platforms which is provided by Intel, which helps you to execute, or which helps you to ensure that some of the key processes runs faster. So what it does is it basically breaks down your application, or break down your you need not specify the threads in your application. Instead, you need to specify the tasks in your application. The TBB in turn takes these tasks and assigns the threads to them. So it logically maps your tasks into threads by supporting parallelism. The advantages of it is supported on all the platforms, that is Linux, Windows, Mac OS, and recently it's supporting Android as well. So you can write code for one, and you can be rest assured that this works across other platforms. So it's a C++ template library. So using this library, you write code for one platform, and you can be assured that the same code without any change works across the other platforms also. The other advantage is it will future-proof your application. So future-proofing means if in case tomorrow you have you are running the application on a newer platform or a newer processor system which has increased number of cores or which has increased number of processors itself in the system, the TBB ensures that it automatically adjusts to the new environment and ensures your application runs faster. So let us look at the components of TBB. In the components, you see the parallel algorithms. It has the partitioners, it has the task groups, and it also has the scheduler. So these are some of the algorithms which are most used in the TBB. That is the parallel for, parallel reduce, parallel do. And what these particular APIs or particular templates do is it breaks down your tasks into multiple small tasks and assigns these tasks into the corresponding thread. So once a particular thread finishes, it automatically assigns a next task to the same thread. So it will not keep waiting for the other threads to complete. So a real world example would be like, if you are constructing a house, the laborers who are working on your house are multi-talented in the sense they can work on masonry, they can work on plumbing, they can work on electrification. So if you have 3 workers who are doing one task respectively, that is one person is working on masonry, one person on plumbing, and one person on electricity, the moment electrical wiring or electrical work is complete, that person will start working on masonry because masonry might take a long time. So he starts working on masonry to ensure that the whole construction process is speeded up. So as I told you, it's the task-based programming. So what are tasks? Tasks are the lightweight entities at the user levels. So the parallel algorithms of TBB maps these tasks onto the threads, as I mentioned. Then it is the work of the task scheduler to manage the thread pool. So the scheduler is unfair. So once a particular thread is complete, it automatically assigns the next thread or the next task which is present in the cache. So it will not ensure that anyone can hold a thread for a long time, or any task can hold a thread for a long time. Also, the scheduler, what it does is it ensures the oversubscription and undersubscription of the core resources is prevented. So this is one of the examples for TBB. It is a parallel reduce function. So you can see the way the functions are written. The way, if it is a TBB function, you need to start the function name with a TBB and double colon. So automatically the compiler understands that it's a TBB function and it loads it ensures that the threading TBB functions or the TBB templates are called. So there are 2 versions of TBB available. One is a open source version and there is a commercial version. Open source version is free for download and you can download it from threadingbuildingblocks.org. At the same time, if you want a commercial version, you can download that from the software.intel.com website. So the difference between the commercial version and the open version is, commercial version you get support from Intel itself, whereas in the open source it's a community driven project. So even there you get support, but not from Intel directly. So for Android purpose, to integrate TBB in your application, you need to make changes to your Android makefile, application makefile, and in your Java source. In your Java source, you need to load 2 more extra libraries, that is the GNU STL_shared library and the TBB library. in the application makefile, you need to set the app_stl flag to the shared flag, GNU STL shared flag. And there are other flags which you need to set in your android.makefile. So it could be the module, it could be the source file, and the shared libraries. So you need to set these flags to include TBB in your application. So next, we will see a range of applications or a suite of products called the Intel Graphic Performance Analyzers. So this particular suite of product contains various other applications which helps you to fine-tune your graphics in your application. So the first one and the key one is something called System Analyzer. The System Analyzer profiles the performance and the power of your application. It gives you with a real-time chart of the CPU, GPU, power matrix, and various other metrics. So totally it gives you up to 3 dozens, that is 36 different parameters you can identify, or 36 different parameter data is provided by the System Analyzer. So how do you use it? You install a APK file, you start this application on your development machine, and then you can start seeing the profile data. So some of the key metrics which is provided for the Android platform are classified under 6 different objectives or 6 different areas. That is the CPU, GPU, OpenGL, power, memory, and the device I/O. So these are specifically for the Android platform. So for the Windows platform, it varies. The other 2 applications which are part of the same suite are the Graphics Frame Analyzer and Graphics Frame Debugger. Graphics Frame Analyzer, you can use it on Windows machine or on the Android, like you can use it for the Android platform. Whereas the Frame Debugger is specifically only for the Android devices only. So Android applications only can be profiled or the debug is the Graphics Frame Debugger. So let us look at a demo. Let me show you a demo on the Intel Graphic Analysis. So since I'm running it on a development machine, I'll be able to show you the Android image. So that is the reason I'm running a sample application on the Windows device itself on my laptop, and I'll be showing you how the graphics system analyzer and the graphic frame analyzer works. So I'm connecting to the local machine. So the moment you connect an Android device to your system, it will pop up here. So you can directly go ahead and connect to it. And it will show you which are the applications it can profile, which are the applications it will not be able to profile. Here, let me profile the cityregister.exe. So these are the different metrics which I've already loaded. So you can see the CPU load on different CPUs, what is the load from the current application. Let me add FPS also, the frames per. So you can see that as I change the size of the window, the number of frames per second also varies. So this is how you will be able to get it. You can download the data into a CSV file so that you can share it with the graphics team for further analysis, or you can save a snapshot of the current frame. You can capture the current frame and use the frame analyzer application or the frame analyzer tool to debug it further. So let me open I have captured frame here. I will open the frame analyzer. So you can see the blue lines here. These are the draw call APIs which have been called in the application or in the particular frame. So let me So when I select the draw call API flag, it will start showing me the different values or the different metrics at that particular instance, like what is the GPU duration, how much of the units were active at this particular frame, etc. You can get the texture here. The pixel history. So these are the different things you can do with the frame analyzer. Next, let me open the frame debugger. So frame debugger, as I mentioned, it is only for Android applications. So frames captured using the Android devices can be debugged using the Intel frame debugger. So this is one of the frames which I had captured a while back from one of the Android devices, from my Android device. So now if I open this image, it will give me the complete list of all the functionalities which were to build this frame. So from the clear flag, it has various calls. So at every call, you can see what is the image which was designed, what particular part of the frame was designed. So let me select here. So the call when the first image was designed or the first image was developed on this frame. So if I click here in this particular function call, it will help me to give more details, or it will help me with more details about this particular frame at this instance. For example, in this particular image, you can see that in this whole frame, image or this particular photo is appearing here. I can make changes to its location directly here. So if you want to debug any debug the locations, you can make those changes here. So if you see, the location has moved a bit left. In the same way, you have other options which you can do using this frame debugger. So frame buffer, let me go ahead and change it again. So you can see the location is changing in the frame as well. So this is how you can use the frame debugger to debug your particular frames and ensure that they are displayed correctly on your device. So next comes something called Intel Integrated Performance Primitives. Intel Integrated Performance Primitives are pre-compiled APIs, pre-compiled by Intel for you, pre-compiled APIs which will ensure that the application executions or some key functionalities are completely optimized for your particular platform. It is, as with TBB, even this is available for all platforms. It is available for Windows, Linux, Mac OS and Android, and the same APIs can be used across the platform, so it is write once, use multiple times. Also, it is future proof and it is supported and updated by Intel. Any new changes to the APIs or any new optimizations available, you will get it. But this is not available for all the domains. It is available for some key function domains like image processing, signal processing, multimedia, audio, video, etc. And the three key optimization goals of the IPP is performance, throughput, and the efficiency. So they are optimized by Intel to such a level that this will be the best optimization available in your application. Here are some of the benchmarks with IPP. There is a function called IPPI filter _8U_C1R. So this particular function, when it was compiled with the Intel C++ compiler, by the way, Intel C++ compiler already optimizes your code to run faster on Intel-based devices. So when this particular function was compiled using the ICL or the Intel C++ compiler, you can see that it took almost 31.8 cycles to execute. Whereas the same function, when you use Intel IPP with SSS E3 optimization, it took 7.21 cycles, and Intel IPP with AVX or auto vectorization extensions, it took just 5.47 cycles. So that is like 342% times and 482 times faster than the compiled code by ICL. Another benchmark, here it is the IPP's square root 32 floating point operation. So when the array length were with various array lengths between 32 and 048576, that is the length of the array, these are the outputs which is seen. You can see that the dark line, which is compiled by the Intel compiler, is always more, has taken more times, all the times, when compared to the IPP with the SSE3 and AVX optimizations. So these are some of the function domains, 16 function domains which the IPP supports. In images and video, it is the image processing, color conversion, video coding, computer vision, rendering, etc. And it is optimized for both 32-bit as well as 64-bit. The only thing with this IPP is that it is available as a 30-day trial version. After that, it is a paid application or the paid tool. This is the only tool which you need to pay to use the functionalities. The rest of the tools provided by Intel are free of cost. Now moving to the developers who use HTML and JavaScript in their applications, Intel also has a tool for you called SDK. So this is a tool which will help you to create, debug and build a HTML5 application for multiple platforms from a single code base. So previously you would have to use different applications for each and every platform, but here a single tool which you can use for multiple platforms. So this is the architecture. You can see that it supports end-to-end from development to building to services. It gives you the complete, it will help you with all the different stages in your application development or application lifecycle. So it has an inbuilt IDE, the development tool for developing. It has more than 30 system images, 30 different system images on which you can emulate your application and see how it looks. There is, for testing, you can use an application called Intel App Preview. So using Intel App Preview, you can install this application on different devices and you can do your on-device testing. It will help you with JavaScript debugging as well as remote debugger. Remote debugger is basically for Android applications. The latest introduction to this application is profiling. So apart from the GPA, this application also helps you to profile your Android applications, which is the HTML5 and JavaScript applications only. So if your application has HTML5 and JavaScript, the XDK tool helps you to profile your application. And for building, it helps you to build the same, like a single code base. It helps you to build packages for various devices, for iOS, for Android, for Windows, Amazon, Nuke, Facebook. It could be also a Chrome application, so the Chrome browser application. So it also helps you build the application for Chrome too. So as I spoke, it has the remote JavaScript debugger. So either you can connect your device directly, the Android device directly to the development machine and debug the JavaScript, or by getting a API or by getting the IP address of your test device, you will be able to debug it remotely too. So App Profiler, if you see in this particular screen, it gives you an example as to the profiling data, how it will look on a functional level as well as the source level. So let me show you a sample of how the XDK looks and how it works. So this is the development window, the of the development window where you can, it gives you the drag and drop options for all the controls. So I have loaded a sample app here, and this is how it looks. It has the logo, it has various functionalities. So this is a full-fledged editor which is present. It's the brackets editor. It comes inbuilt with the Intel XDK. So once you're done with the development for the emulate part, you can, if you go to the emulate window, so this is the emulate window, and you can see some of the emulators which are available inbuilt with the XDK. So you have Apple product, you have Google product, you have Microsoft Surface Pro, you have the Samsung Galaxy Tab as well as the Samsung Galaxy S, and also you have Toshiba Satellite Ultrabook. So these devices keep on updating. You can load more devices too. Like if you get the system images of these devices, you can load your custom devices too to the emulator in XDK. So I am emulating like on an iPhone 3GS. This is how the application looks. So the vibrate functionality. Then for testing and debugging, you need to log in with your credentials. You need to create an Intel XDK login. And once you create an Intel XDK login, you will be allowed to update or upload your image or upload your application to a server. And using the Intel app preview, you can download this application on different devices. So app preview is available for Windows, Android, Windows Phone, iPhone, like iOS. So it is available for both iPad as well as iPhone. Once you download the app preview, you need to log in with your account, the same account what logging on your SDK. You will be able to see your application loaded there, so you can download your application and perform your testing on the device. For debugging, the steps provided here is for USB debugging, but you can also do a remote debugging, remote JavaScript debugging. It will ask you to, you will have to include a statement in your HTML application. So once you include that, automatically you will be able to debug your applications remotely. The same thing with profiling too. So for profiling also, either you have to connect your Android device, or you have to connect your Android device. There is no option for you to do a remote profiling yet. And finally, the building process. In the building, you will be able to build a application for different. Let me log in with my credentials. So these are the different platforms for which you will be able to build using the Intel XDK. So for on Cordova 3.x based mobile application, mobile platform, you can build for Android, iOS or Windows. In the legacy applications, these are the other platforms which you can build. And if you want to build it as a web app, you have Chrome, Facebook, or the latest, it also supports the Firefox. So direct building this gives you the corresponding setup file. It could be a APK in terms of when it comes to Android, or it could be your iOS application, setup application when it comes to the iOS devices. So these are some of the tools which you can download. There is another tool called the Intel Indie. or the Intel Integrated Native Developer Engine. So what it does is in a single screen or in a single window, it will provide you links to all the different applications which Intel is providing for the native developers, for the native Android developers. So let me open up the Intel Indie screen. So you can see that in a single window, I have all my different applications or different tools which I spoke about. You can see that it is present here. So it has the threading, that is the TBB. It has the GPA, that is the graphic performance analyzer. So there are 4 different applications which are part of the suite, of the GPA suite. It allows you to install all of them individually. Then the environment setup. This is the one where it automatically installs the Eclipse. It installs the latest version of NDK, SDK, and it installs Hacksim for you. The media set of media libraries. So once you click on a particular application here, it will give you the description as to what exactly this particular application, this particular tool is for, and then you can download and install the same. The advantage of this tool is, rather than keeping a track of what are the new tools which Intel launches for the native developers, it is a window where automatically once you open it, it's an auto start during your Windows boot up. In a single window, you will get to know what are the new tools. So as and when new tools are launched, it populates here, and you can directly go ahead and download, install the applications or install the tools. So this is one tool which you should download first. It will help you to download the other tools which I spoke about today. So we are open for questions now.
Thanks for insightful presentation on maximizing app performance using Intel tool. Let us quickly take up the question now. I request our guest speaker to please read out question before answering them. It will help to understand question in a better way. So let us take our first question, and I request all of our audience, if they have any question, they can share it with us. Are you able to check out the question, Ghanshyam?
Yeah, I just got it. So, Manoj asked, like, can we integrate the code in our Android native applications? So, Manoj, if you can specify as to what exactly is, which code you are talking about, I will be able to answer you in a better way.
Here's all for the code you have shared in, I think, 3rd or 4th slide.
3rd or 4th slide. Let me see that. This is about the TBB, the threading building blocks. Yes, you can integrate this code in your current Android native application also, and you will find that there will be an improvement in your performance. Okay. Next question. Can we develop any app for any platform on Intel XDK? Yes, as long as the application is for is HTML5 and JavaScript based, you can develop application on XDK for any platform. So Manoj, I believe I answered your question. Like, you can integrate the TBB with your existing applications too.
So there is another question from Mr. Asif. Mr. Asif, can you please take that one, Ghanshyam?
Yeah, as if I just told, can we develop application for any platform on Intel XDK? So as long as your application is HTML5 based and HTML5 and JavaScript based, you can develop application for any platform, any of the supported platforms. So XDK is free for download. So go ahead, download XDK. If you want XDK separately, you can download it from the Intel website. If you have, if you want other tools too, other tools which I spoke today, you can download Indy and the environment setup. The environment setup will also install XDK for you.
Can you please pick the another question?
No, like I think Manoj was a continue question from my first question. I have heard it.
Okay, means it's like the same question, right?
So since I asked him, I think Manoj has clarified it.
So I still urge all my audience, if they have any question, they can share with us. We will ask Ghanshyam to clear their doubt. Ghanshyam, I request you to please.
Let me share some key resources. Yeah. Okay. Suppose I have and want to integrate this app for increased performance. So Indrajit asks, how is it different from PhoneGap? So Indrajit, I have not used PhoneGap personally, so I will not be able to comment on this. But one of the advantages is it also it gives you the complete development for all kinds of devices, and it gives you option for emulating or running, seeing your application run on different platforms. So I have not used PhoneGap. That is the reason I will not be able to comment on this particular question. One app, then Asif again asked me, like, one app developed on one platform can run on any device. So Asif, since you have emulator, you can just check that. There might be some minor changes you need to, like minor tweaks which could be required so that the application runs smoothly on all the platforms. So once these tweaks would be done, you should be able to run the same app. That's what I told you. So XDK is a tool where you have a single code base and you're able to develop applications for multiple platforms.
Ghanshyam, I think we are done with the question and answer round. We are not getting any much question on this.
Yeah,
so you want to stay for some more time, or in discussing some other related thing, or we should wind it up?
Like, I'll just paste these two links. If you can share these links with all the attendees, that will be helpful for them.
Right.
So the best site to get all the information.
So you have already said that. You have already shared the desktop. Yes, you have already shared
the desktop. I have shared the desktop.
So our
so in the chat you can share it with the attendees. That will be helpful as well.
Meanwhile, we are getting a second question from Indrajit Singh. Hopefully, if you can take that question also, Ghanshyam, it will be good.
Okay, let me just check. Yes, Indrajit Singh is asking downloading SDK, Indy, environment setup is free. Yes, all these three are free, Indrajit. Just download Indy, and from Indy you will get links to all the applications. As I mentioned, IPP is the only tool from Intel for which you need to pay. So it is not present in the Indy also, because since it is not a free tool, it is not present in Indy. Any tool which comes up in Indy is free for use. So you can use that tool and you can develop for Android or the different platforms. So these are my contact details. You can email me, you can add me on Facebook. You can follow me on Twitter. If you have any questions, please feel free to email me. As soon as possible, I'll respond to your questions.
Right, Ghanshyam, thanks a lot. You can also visit our website where our user can post their question, right? Once we are done with session,
sure, yes, I will do that.
Within a week, you can just visit our website, techgate.com. There you will find all the question if there is any, right? So I'm really thankful to our guest speaker for conducting this webinar. It was indeed a great session. I would also like to thank all our participants for their support in making this webinar a success. The recording of this webinar will be available on our website, that is techgeek.com, by tomorrow. Thank you all. Thank you, Ghanshyam.
Thanks, Gaurav. Bye.